Motor learning, just briefly, I'm not going to go too much into that, but basically different parts of the motor system have different roles in creating motor learning and motor memory. The cerebellum is responsible, as it says here, continuous adaptation of motor programs based on comparison between the internal model and visual and somatosensory feedback. So we spoke a little bit about the organization of the cerebellum, and we had these two different inputs, climbing fibers, mus fibers, to the Purkinje cells. And this is part of the organization which makes it possible for the cerebellum to have this precise role. So basically the way that the cerebellum is seen now is that it's kind of a learning machine. So what it does is constantly to compare what the intended movement was to what the actual performed movement was. So it's comparing the motor program that the brain is sending to the muscle to the sensory feedback, which reports how the muscles were actually being moved and how it interacted with the environment. So based on that, and it can sort of calculate whether everything went according to the plan or whether there was something which went wrong. So if something went wrong, what can be done is to issue an error signal, and there is evidence suggesting that the climbing fibers are responsible for sending this error signal and having the cerebellum update the motor program so that it becomes more appropriate the next time the movement is made. We have parts of the basal ganglia being involved in what is called implicit sequence learning, which is basically if you have to learn a certain sequence of movements. If you do that training just based on visual feedback, for instance, you become better at doing it without actually explicitly knowing that you had a specific sequence. So if there are sort of sequences built into a sequence of movements, but you don't consciously recognize it as a sequence, you still become better at doing it if you repeat it several times. So if you have a long sequence, so for instance, you're told to put your thumb on your little finger, then on your index finger, and so on, just one after the other. And you don't realize that in that long sequence, there are actually hidden subsequences which keep recurring. So that one specific pattern, putting your thumb on your little finger, then on your index finger, then on your ring finger, that particular three-digit sequence is repeated much more often than other sequences. And because it's repeated more often, you become quicker at doing that exact one, boom, 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 because that was that sequence. But you don't realize that that sequence was actually there. So that's the implicit sequence learning, and that's the basal ganglia which does that. So it's subconscious, you don't have to memorize it. We know that the actual motor areas are involved in optimization of movement parameters, precision of movements. So if you have to make a very precise movement, like threading a needle or whatever, you need optimization in those areas. It's also speed of movement, coordination, and it's coordination of muscle activity and tuning of reflex contribution, which takes place at the spinal cord level. So basically it's distributed all over the motor areas. And explicit sequence learning is then in the premotor areas, especially the supplementary motor areas, where you can have this also mental memorization of the exact sequence that you were to do. So that several different areas which work together, making it a rather complex thing. Now, going further into the implicit learning, we certainly also have emotional content that we can remember. Again, it's not something which is explicit as such. It's difficult to explain just how it feels to be in love or be angry or whatever. It's a feeling that we have, and we can all recognize it when we have it. So we're also able to when we remember events, to re-experience that feeling that we had when that event happened. So we're also able to sort of remember, in a sense, how that feeling was at that time. But the interesting thing is that these feelings also influence our explicit remembering of what took place. So it's obvious that when there is some kind of emotional content, we tend to remember things better. So in some years ago, but there aren't that many people alive anymore who can actually remember when John F. Kennedy was shot. But that used to be the thing that everybody could sort of remember where they were when they first knew that John F. Kennedy was shot. For other people it has been when Elvis Presley died. I don't know if it's now when Michael Jackson died or whatever, but usually, sorry? 9/11, also a possibility. Maybe everybody now remember where they were on 9/11, 2001. So at least some kind of emotional content make us better at remembering. We know that the amygdala, which are two small nuclei which are located in the central part of the brain and connected also to the hippocampus through various pathways, and very closely involved in also the whole emotional aspect. We're going to come back to that later on when we're talking about emotions and feelings, but they're also closely related to the hypothalamus, which is controlling the endocrine system, and also therefore controlling the reaction of our body to whatever emotional stimulus that we have. So when we feel angry, there's also a reaction in the body. When we have experienced fear, anxiety, our heart is beating, etc. And that's all due to influence from the amygdala onto the hypothalamus, onto especially the sympathetic nervous system. So, but it also influences our ability to remember things, which is shown here. This is patients who have lesions in both amygdala, and it turns out that they are just as good or as bad at remembering anything in the past, whether it has an emotional content or not. So this is an experiment which was quite simple in design, telling a simple story which had sort of three phases. The first phase being neutral in emotional content, second phase being highly emotional, and the third part again being neutral. So when subjects are told to remember this story, usually they remember the middle part much better than the first and the third part. So the story could simply be that a woman and her daughter are walking down the street, so it's not very emotionally, not very much emotional content. Then they see their father coming to approach them, but at the same time there's a car which hits him. So high emotional content. The third part could then be that, but nothing really serious happens, and he comes and greets them again, whatever, so that it's sort of not as emotional. So most people will then remember that the car hit the father, etc., but be less good at remembering the other things. People who have this amygdala lesion, as you can see, are good at remembering the first phase, but gradually worse and worse at remembering the other bits, and in particular not very good at remembering the part with the emotional content.